An AI agent can produce code that looks finished. The structure is convincing. The names make sense. The implementation seems to match the assignment. But if the agent's environment can't reliably prove what works, what does finished actually mean? That's the question that separates code output from working software. Plausible code is an artifact. Working software is code that's been evaluated against the expectations of its repository. And the difference isn't simply a better prompt. It's the whole system surrounding the work. A coding agent needs repository-specific instructions, a configured development environment, reliable tests, and clear documentation. Each piece supplies information that the code by itself can't contain. Instructions establish the local rules. Configuration makes the repository usable. Documentation explains its intended shape, and tests provide a repeatable way to check behavior against expectations. So, a working test suite helps close part of the gap between code that appears correct and code that can actually be checked. It doesn't make the result infallible. What it does is give the development process evidence that goes beyond appearances. Developers often picture tests as a gate at the very end of the process. Implementation first, verification later. But for an AI coding agent, that framing misses an important role that tests can play. Tests are part of the feedback available while the work is being evaluated. They're not merely a final ceremony after the output arrives. Think of the environment as a connected stack. At the top, you have repository-specific instructions, the local constraints that define acceptable work. Beneath those instructions is a configured development environment where the repository can be examined consistently. Clear documentation adds intent and context. Reliable tests turn selected expectations into actual checks. When one of those layers is missing, the feedback loop gets weaker. The code might follow general conventions while still missing repository-specific ones. A task might sound complete while remaining difficult to evaluate. The point isn't that tests can answer every possible question. They can't. The point is that dependable work requires an environment capable of asking concrete questions about the output. That's why the test suite belongs conceptually beside the instructions and configuration. It's part of the workspace that makes verification possible. And that feedback loop begins before implementation. Complex coding work should be divided into precise prompts that contain concrete examples of expected inputs, outputs, or implementations. The word concrete really matters here. A broad instruction might communicate the general direction, but an example gives the intended behavior a visible shape. An expected input identifies a condition. An expected output identifies an observable result. And an implementation example can clarify the requested pattern when that pattern is itself part of the assignment. That creates a useful connection. Repository intent becomes an explicit example, and that example points toward an outcome the tests can evaluate. The prompt defines what the assignment is trying to accomplish. The tests provide a way to check selected behavior. This isn't a prompt engineering trick that somehow replaces the rest of the environment. Precision works because it connects directly to verification. Without concrete expectations, a polished implementation can still leave everyone debating what success was supposed to mean. So, before complex work begins, ask whether the assignment contains enough specificity for the result to be examined rather than merely admired. Imagine the task as a short chain of transformations. This isn't a fabricated repository scenario. It's a planning model. First comes the intent. Next comes a concrete example of an expected input, output, or implementation. Then you get an observable outcome. Finally, reliable tests can check the behavior they cover. Every link in that chain reduces ambiguity. Improve this behavior leaves a large interpretive surface. For this stated input, expect this stated output. establishes a much more definite target. The agent still needs repository-specific instructions and a configured environment, of course. But now the assignment and the verification process can point in the same direction. This approach also exposes missing information early. If no one can state an example or an observable result, then the task might not yet be precise enough to verify. And that's valuable feedback to get before a large body of code appears. The goal isn't to encode every possible requirement into one prompt or one test. It's to make the work incrementally checkable by connecting instructions to examples and then connecting those examples to evaluated outcomes. Now we reach the midpoint trap. The tests pass, so the work must be safe to accept. That conclusion goes further than the findings actually support. Passing tests give you information about the behaviors those tests evaluate. They don't establish that every dependency suggested by an AI agent is legitimate or safe. Dependency verification is a separate responsibility. A package name can sound completely plausible, but that isn't evidence that it should be added. Every dependency suggested by an AI agent needs to be verified instead of trusted automatically. And you can't outsource that check to the green status of an unrelated test result. The distinction is simple, but it's important. Dependency verification asks whether an external addition is legitimate and safe to introduce. Those are two different questions. Success on one doesn't answer the other. So, all tests pass should never silently expand into every aspect of this change has been proven. Tests remain essential feedback, but their boundary has to stay visible. Dependable development combines behavioral evidence with deliberate scrutiny of suggested dependencies. Some assignments stretch beyond a single working session. When that happens, continuity becomes part of the environment too. Long-running agentic development should be divided into incremental sessions, with explicit artifacts left behind to preserve context for the sessions that follow. Those artifacts can record what was attempted, what was verified, and what the next session needs to continue. The finding doesn't prescribe a particular tool or file format. The property that matters is persistence. Without a durable record, the next session might receive the repository without receiving the reasoning state surrounding the work. It might not be clear which expectations were already checked, which questions are still unresolved, or where the next increment should begin. An explicit artifact takes that fragile context and turns it into something inspectable. It supports a handoff from one session to the next, and it keeps the feedback loop from resetting. Incremental sessions also give the work clearer boundaries. Define a portion, evaluate it, preserve the result, and then continue from the recorded context. The artifact doesn't replace tests, documentation, or repository instructions. It connects those elements across time. A useful handoff can be understood through three questions: what was attempted, what was verified, what must continue next. The first question preserves scope. The second preserves evidence. The third preserves direction. Together, they give the next session something more useful than a vague statement that work is in progress. Notice how closely this mirrors the broader development environment. Precise prompts define a bounded assignment. Reliable tests contribute verification. Repository instructions and documentation preserve local expectations. And session artifacts carry that state forward when the work spans multiple increments. This matters because longer assignments don't only accumulate code. They also accumulate decisions, checks, and unfinished edges. Preserving those things explicitly makes continuity a designed feature of the process, instead of an assumption everyone hopes will hold. Put all of these pieces together, and a practical AI development stack starts to appear. Repository-specific instructions define the local rules. A configured development environment gives the work a consistent place to happen. Clear documentation communicates relevant intent. Precise prompts divide complex work and include concrete examples. Reliable tests check the behavior they cover. Dependency verification scrutinizes external additions, and persistent session artifacts preserve continuity. These aren't isolated tips. They reinforce one another. Instructions without examples might leave a task too abstract. Examples without tests can remain assertions instead of becoming evaluated outcomes. Passing tests without dependency verification leave a separate question unanswered. And verification without persistent artifacts can lose continuity when the work crosses sessions. The agent becomes more dependable when it participates inside this system. The system defines the task, exposes repository expectations, checks the output, verifies suggested additions, and preserves the state of longer-running work. The mental model is straightforward. Dependability comes less from how finished the code looks and more from whether the surrounding environment can produce relevant, durable feedback. So, when should an agent's work actually be treated as finished? Not merely when the code has been produced, and not merely when it looks convincing. The stronger standard is a process that can verify behavior, scrutinize suggested dependencies, and preserve enough context for the next session whenever more work remains. That standard still requires repository-specific instructions, a configured development environment, reliable tests, and clear documentation. None of those elements promises complete correctness, but together they make the output more accountable to the repository where it has to work. This is the central shift. Don't treat tests as a final checkpoint that appears after the agent finishes. Treat reliable tests as part of the environment where the work is defined and evaluated. Support those tests with precise examples, separate dependency verification, and durable session artifacts. At that point, finished stops, meaning the output appears complete. Instead, it means the work has reached an acceptable point inside a process that can check what matters and carry forward whatever remains. Before you refine another prompt, audit the environment around it. Does the agent have repository-specific instructions? Is the development environment configured? Are the tests reliable? Is the documentation clear? Are concrete expectations included in complex assignments? Is every suggested dependency verified separately? Can context survive into the next session? The weakest answer in that list might tell you more than another round of wording changes. The prompt matters, but it operates inside a much larger system. Improving that system gives the agent clearer boundaries, better feedback, and more durable continuity. If this helped you rethink your AI development stack, subscribe to Neural Stack and share in the comments which part of your agent environment you'd audit first.